Working on electronic equipment has many hazards associated with it that can cause injury and/or death. Please do not work on energized equipment unless you take proper precautions. Working on such equipment is done at your own risk and not at the prompting of information from this or any other YouTube channel. Hello and welcome back to Poor Man's Electronics Bench. In this final part, I am going to work on a few small modifications to my new-to-me HP E3612A DC power supply. In part 1, I covered researching an apparent design flaw that had some of the capacitors on this model type, the E36XX models, failing with age on one bus, while the opposite polarity bus with higher voltage rated capacitors were surviving just fine. This part will cover 3 small changes that will at least keep some PC board damage from occurring, clarify output connection points with proper color coding, and install more functional control knobs in place of the small stock knobs used for adjustments. As a final bit, I will be obliged to stress-smoke test the unit while observing it with thermal imaging camera to give it a final check before calling it done. I hope you stay tuned and enjoy the video and the information. Before I get involved in my shenanigans, I wanted to backtrack a little bit and go over another example of a problem with these Hewlett-Packard E36XX model power supplies. There is a website called Emperor of Test Equipment.weebly.com. This person apparently has purchased a large amount of different brands and models of test equipment over the years and has had experiences with working on repairing them, restoring them, getting them back into service, and I'm not sure if he collects them all outright or resells some of them or what he has going on, but he has quite the interesting and large collection of items that he has had experience with. And there's some good information for people who would be interested in browsing his website. I will put a link into it. It's got some interesting notes on just about everything he's worked on. One of them is an HP model E3611A power supply. I'll read off his site. It goes, basic, no frills, 30 watt linear power supply in 2 ranges, 0 to 20 volts at 1.5 amps, or 0 to 35 volts at 0.85 amps. There are a bunch of HP E361X models to choose from. They were manufactured in the early 1990s when HP was in their let's build cheap stuff phase. While the design and electrical components are fine, the mechanical design really shows how cheaply they are made, albeit it must cut down on some assembly time. For instance, the boards snap into the plastic case, and the case itself snaps together. There isn't a single screw anywhere to be found. Certainly not for precision work. This supply was only $300 in 1997 and is designed for general lab use. It does have a current limit switch on the front panel that eliminates the need to short the output, and that's a plus in my book. And he grades the items that he worked on. He gave this a B+ for its general performance and design and everything else. And his notes for repairing are, advertised as not accurately displaying output, which must be what the seller noted when he put it up on eBay. The eBay photo showed the unit with both the CV and the CC LEDs lit. Well, you can't have a power supply doing constant voltage and constant current simultaneously, so obviously the E3611A was broken. But the price was right, $20, and I needed something to fix. Upon receipt, the output voltage was changing as I turned the front panel pot, but the display was nonsense, as the seller indicated. When I snapped open the covers, there was a board full of seeping electrolyte and 2 330 microfarad capacitors that were obviously puffy. I removed the electrolytics, and it was only those 2 that were toast. The leaking caps were Nichicons, and I was somewhat surprised that these failed given Nichicon is a top-rated brand. However, they were about 1/4 inch away from the main transformer, which can get quite warm. Probably a minor thermal fault design on HP's part. Cleaned everything up, replaced the caps with 470 microfarad caps that I had in a junk box, and the unit responded correctly. The only other fatality was a sheared off negative output banana jack on the front panel. Again, a brief consultation with my junk box remedied that. There were a couple of broken fins on the rear panel heatsink, but that is a non-issue given only the 30-watt capability of this supply. Well, he ran into part of the design problem that the 3612A, the higher voltage models, have. In the 3612A's case, it only had one 330 microfarad capacitor. The other one was a 470 microfarad, and it was the 330 that have been giving people problems if you go and look on other people's YouTube videos for this unit. So I ended up changing mine also out both the 470. One was a 470, but I put fresh capacitors in, changed them both to 470s. I kind of dispute his claim that the capacitors were heated due to the power supply transformer, because I found that the power supply transformer in this unit actually operates fairly cool. I thermal image checked it, and even after load testing it, there was no obvious sign of that transformer being stressed to the point where it was heating those capacitors. And the one thing about those capacitors also is they're only involved in what would be onboard or maintenance data duty. They're not part of the actual output on the unit, the power output. So they're not really stressed anymore having a load, but it's just something to do with that AC voltage coming off the transformer, just the hitting continuously those capacitors that after they're, even though it's rectified as full wave, it doesn't like those peaks as much if it's a lower voltage rated and capacity capacitor. That the capacitors, like I said, the one was 470 at 50 volts when I purchased this unit. That was fine. And even though the lower one was a 330 at 35 volts, it still over time failed on other people's units. So that's why I decided to change both of them and go through the effort of making a video to document this for other people that might want to purchase one of these, so they know if they have a problem, that's going to be one of the first things to look at. So I'm going to proceed with the rest of the video from here. Hello and welcome back to part 3 and the final part of working on my Hewlett-Packard E3612A power supply. I've restored functionality to it as far as replacing capacitors and verifying the fact that it does still have an output. I am going to take care of 3 small modifications going forward from here, and then I'm also going to do a little bit of a stress / smoke test at the end of this episode, just to make sure that this can be functionally put back into service and not worry about things too much. 3 of the modifications are going to do, it's nothing earth-shattering. It's one of them I've seen on a different channel for repairing one of these units before and modifying it. They ended up figuring out that the outputs on the front of the unit, the 5-way binding posts, they have a peculiarity as far as the markings, where you have a positive, negative, and a ground, but you have both of the positive and negative are marked color-coded red for some reason, and then the ground, and it says plus 240 volts DC max underneath it to ground, plus minus. I don't think I've ever gotten any potential from ground going off of the negative to a ground on this particular voltage tester. I can double check that to make sure, but it doesn't seem like it's something that is going to happen. But what I'd like to do is be able to change these binding posts to a new ones for 1 and then for 2, so they all match, and then I'll have this one positive is red, negative is black, and this one with a green color code for a ground on it. That's one modification to do. Second modification is this unit unfortunately came used with only missing one of its knobs, and searching around online to try to find a new knob for this one, it was practically impossible to find a new one for a low value for just to replace that one. Did some digging around, and they actually found on digikey that they make some knobs for some other Hewlett-Packard equipment that are interesting as far as being able to be used on this. It has a metal D-shaped insert on the back of it that matches the configuration for the adjustment. And what this lets you do is, once you install it, is instead of taking all this time and effort to turn that voltage, you can give your... Seems like it's just a little more practical and easier to use, and these do fit side by side, which is even a bonus. The only downfall to them is they do cover up the voltage and the current markings on the knob, but I could fix that with a P-Touch label maker and some clear label, black on clear, to go through there, and you can adjust the voltage and the current very easily with one finger instead of having to do multiple twists and turns of a knob like that. Now, the only thing about these particular knobs is they do have quite an offset on the back side of the knob to the front of the chassis. Just for example, here, this is the offset is probably not quite a 1/4 inch, but it's pretty close. And what seems to be happening is just the lengths of the front of the potentiometer shafts are a little long, because this isn't too deep. But what I figure I could do is, there is a bit of plastic in the way in here before it gets out to the actual front plastic of the knob itself. It seems like there's a little ridge in here. What I'm hoping to be able to do is to take a die grinder tool like this and set it to depth on the die grinder, where I can just take a little bit more of that plastic out to let that sit further in, and hopefully I can do that without carving out the front of the knob. That would be quite tragic if I did that, but if I can do that, I can make the knob sit down a little more and look a little more attractive on the unit. So that's items 1 and 2, and item number 3 was something that I found when disassembling this unit. It's just going to take a second to fix with a Dremel tool as well. What's wrong is the bottom of this chassis has a plastic pin that sticks up from it, and it actually pokes onto the printed circuit board. It's not a very long pin. It's this one here. And I showed before how this actually has a little bit of an indentation in it from the traces where it's touching the printed circuit board. And if you look on that area, looks to be somewhere about right here on the printed circuit board. There's really, it's so close to the front of the unit, it shouldn't need any extra support anywhere. And all I can see that doing over time is if this printed circuit board gets bounced up and down inside of the unit too many times, is it'll eventually wear into and or crack the printed circuit board and or wear the trace out. I really don't see the use for it, so I'm going to plan to cut that down with a Dremel tool and a saw, Just a little more. It doesn't need a lot of clearance, but it'll just give it a little more where it doesn't bump into the board and cause a mechanical rubbing against any contacts. And then other than that, I probably could go over the bottom of the board. I left some markings on it, and I can go over the bottom of the board and clean things up a little better. I didn't do a great job of that after my soldering, but that can be accomplished in a matter of doing things. And then as the last part of the testing, I have some resistors I can make a load out of. I have an assortment of 500 ohm resistors. I've got some larger 100 watts, and these are 20 watts. So I was planning to hook 4 of these up in parallel to get me down to 125 ohms. That would get me close to a half amp load at 60 volts. One of these resistors will get me on the 500 at 120 volts will get me a quarter of an amp, which is the maximum output rating for the unit. So I'm planning on running those voltages for about 5 minutes or so on each one, just to make sure that the unit can operate without anything burning up and be able to handle the thermal stress over about a 5-minute time period, because that's usually about all you need to run something like this for. So that's my plans for going forward and finishing this guy. So stay tuned and I will cover what I'm going to do next. I started out with the intention of doing some work outside, trying to keep the dust and debris content inside in the minimum, and this is the one pin on the bottom cover that was contacting the bottom of the printed circuit board. And if you see those little grooves in there, those are actually the traces, the copper traces of the printed circuit board imprinted into there. And I decided to create some clearance on that just to keep that from wearing through the traces. And there's evidence of this safety gear using a Dremel tool. Figure I'd cut down the noise content a little as well. Got a little saw blade hooked onto there and just ran it at a low speed, just low enough to cut it and create some clearance. This could be done could have been done with just a file as well, or hot knife, any other means somebody wants to do it. This isn't a thou has to type deal, so people can be creative and how they'd like to accomplish that, but that's the tool I chose, and that and a little bit of filing to smooth the plastic out, the rough edges of the plastic out, and seemed to create enough clearance to fix that issue. In the second part of the outdoor video, I'm just going to speed through it real quick. I tried to make an effort to cut some more plastic out of the inside of that knob to let the knob sit more flush on the panel. It was an unsuccessful attempt because either I just couldn't remove any more plastic, or there was actually a shoulder on the knob shaft that prevented it from going any further. But I just kind of show you my efforts. I used with a Dremel again and a narrow router bit, just writing on the inside of that diameter of that D-ring fitting without going too deep and cutting through the front of the knob. Hello, and we are back indoors, and I have the finished products of the knob. I managed to get as much plastic ground off as I can out of the inside without disturbing the plastic on the outside from the inside, which was good. And take a little bit of a look inside here. I got rid of that little plastic ridge inside of the knob pretty well. It was able to get it a little more depth on the face of the unit, but I'm not going to put these on right now because I'm going to pay attention to the main part of the work here is going to be changing out these binding posts here. Now physically there's nothing wrong, you could leave them, but the thing I don't like about them is the markings and the coloring is misleading because it's marked, if you see, it's marked as a positive, negative, and kind of like a chassis ground, which would actually be also your line cord ground as well. There, and also on the bottom it says plus minus 240 volts DC max to ground. Now that tells you that maybe that would be something in case it got bridged onto other power, but it's also a little misleading because it kind of leads you to believe that you would actually have the ability to go plus or minus on voltage, and you don't on this unit. It's going to be just your potential is going to be between the positive and the negative, and the return to ground marking on the lead has nothing to do with any type of power output on this unit. And going online, I did manage to source a kit of replacement white colored binding post, which is nice. Kind of matches the theme of the unit, white or very light gray. And it gives you an assortment of green, black, red, and blue, and yellow. And the only ones I'm really going to be interested is the green, black, and red. Because what's going to happen is we're going to replace our black ground with an earth there, and in order to keep things matching, I will replace these and go positive, negative. I do like the fact that they've got a little bit bigger plastic colored marking on them too, so I'm going to head off in that direction here. So you get this box shut for the remainder of the parts. So in order to do that, I'm going to have to do a little bit of mechanical rework and resoldering. I did manage to do a repair on the rip on the front cover on this. If you can see off to the left by the on-off switch, it had a bit of a tear. I got in, cleaned up everything as good as I can behind there, and I got, I think I think I used some, I can't say if I used two different glues or not, just to get the thing to finally sit in there, but it seems to be in there kind of flat and good enough where it's not coming back apart. I think I used a Loctite super glue as one of them. So the front panel looks fairly acceptable. I did polish up the plastic over the digits too a bit, and you got kind of any major scratches and haze taken off of there as well. So now the challenge is going to be to get this front part taken apart, and in this case there's a couple of header pins to go to the printed circuit board, or at least one I was able to loosen to give it some slack between the two boards. So that does give you the ability to lift it off and get a little bit better working position. On the binding posts, we have kind of like a multiple connection scheme going on, where there is the positive has two wires, the negative has two wires, and the ground to return has two wires. So got the old Heathkit chassis soldering iron. GH17A. Going to see if I can't get enough heat on there to take these wires off. we'll continue on this path and see where it takes us. I just realized I am having a brain fart kind of a day because this particular banana jack here has hardware with some plastic washers on it already. We're going to see how it fits up without doing any modification. This has seems to have a couple of pins on the side of it. Well, it's not exactly a press fit. It's just a little bit big, but I think a little bit of modification along the lines of just trimming down some of the plastic on one side might be in order here. Going to give that a try. I'm just going to take some clippers and soft enough plastic where I can cut some of it off at least. Took a chunk out of the one side. Maybe take a little more. There, I got most of everything on the one side off. That should give it the ability to mount into that hole nicely, and it does. So that one is going to be our positive. I decided to go back into the disassembly of that solder joint. I really didn't like the way it was turning out. I wasn't really sure of its mechanical bonding. Since I didn't want to sacrifice any more insulation on the wiring, to get new wire, clean it up, wrap it around there in a good mechanical fashion, and I decided to go with a mechanical fastening route using the hardware. Now what I'm going to do is use a crimp-on electrical lug, and I'm going to put two wires into the lug. It's normally not a approved, or let's say a not frowned upon practice, to use a connector like this as a connection point between two wires in the crimp, but what I am going to do is, these lugs are tinned, so crimping them and then putting some solder on there, as well as got a crimp on the back. I just used a common crimping tool available in most hardware stores, the 16 to 10 position for the insulated wires. I just put a good crimp squeeze on the back side. And I'm going to heat this guy up a bit. Those wires are already tinned and this readily accepts solder, and it'll give you a good solder joint within the connector. There shouldn't be any type of metallic corrosion since there's no dissimilar metals. These are copper plated with tin, and it's going to be a lot better connection. The only thing I need to do is get the blob of solder that I made on this guy off of here so I can get it past the threads. Hopefully I cut most of it off. And this will make this assembly, for any reason, a little easier in the future as well. Little general overlook just before I put things together to make sure nothing's really out of the ordinary. And it all slides together very nicely. And the finished product Gives a good appearance of 3 properly color-coded binding posts. Now I'm going to try to place our knobs on the front. Use this guy as a spacer. If you remember from earlier, they were protruding off the front a little bit, so I decided to take some plastic off on the inside of them. Can't say I made them fit a lot better here. I don't know what the holdup is. Tried my best to get everything out of there that I could. Being at a point where I just have to carve out what's left with the screwdriver. Can't say that I really got it to sit down a lot more than it was before, even though I took out as much plastic as I could. The only thing I could have done different is taken out that metal spring clip, but I was using that as a guide to make sure that I didn't remove too much plastic. But even so, it looks like I'm going to go with that. The only thing I'm going to do differently is mark those 2 positions now. I have a P-Touch labeler. Be nice if I can find some black on clear, but I'm not sure if I have any. Well, looks like I am relegated to black on white. These are handy little labelers. I have a career of using these for quite a while. So I just want to print up a simple voltage and current, 2 lines. Oh, I don't want to frame out. Gotta check your settings and all this stuff here. I've got a frame. These are quite versatile for labeling things. Frame off, that sounds good to me. I'll print it again. These are a little expensive new, but you can find them on the used market as well. They make this labeled size down to, this is a 1/2 inch, they make this down to a 3/8. A lot of times I just make smaller labels out of the larger ones by printing them and then cutting them down to size. If you don't want any extra tape on there, you can cut off the rest of it. I'm just going to park him there for now. Definitely have to put the premise in this video where all of this isn't the only way to do it. This isn't the be all end all. Thou must do things exactly like I do them. You can, whoops, you can be creative and apply your own methods to the process, and odds are it'll work just as good as anything that I've done. You don't have to put those mechanical connectors on. You don't even have to change the binding posts. You can make a different labeling scheme. You don't have to change the knobs. In my case, it was just kind of out of necessity because I only had one knob, so out of the two. So that gives a good overview of the needed work. I think I showed taking down the piece of plastic that was hitting up against the printed circuit board. So I'm going to put the bottom of the unit on. That won't hurt anything. I'm going to take a quick look at it because before I do that, because the bottom's going to, before I call it finished, because the bottom will probably stay on during the next part of the video, where I am going to do a little bit of a heat soak test slash torture test just to let it run into a load and examine it and make sure that it's not going to cause any major issues with anything going forward. I didn't see any, didn't look at everything really close. I probably should take a minute and get the old magnifying glass out and just make sure that I don't have any solder joints that are cold and breaking loose. Going through all this work, it would be a shame to go put it into production just to find out that you've got an intermittent issue. Doesn't have to be anything too fancy as far as a magnifying device, just anything that you're comfortable going over it with. Some people might take the time to reflow the whole thing, but don't think that's a necessity in a lot of cases. If the majority of them look like they've been soldered with good heat, they're not crystallized, and a good exam of the whole board will just give you a little bit better peace of mind. Okay, looks like that part of it's taken care of. I'm going to Put the bottom on. Quite the snap together assembly here. Almost forgot my header pin. Okay. Has a bottom, so it's insulated. So I'll take a, oops, sorry about that. Take a little break, get a couple of cables and some load resistors, and we will carry on with the festivities of doing a load test. Going to do a quick general functionality test on the meter, on the unit, just to make sure its display is reporting fairly correctly. We have a voltage range up to here. It's set for the low range of a 1/2 amp, so it should go up to at least 60 volts, which it does. Constant current set in this range will take it up to 0.5 amps, 500 milliamps. That control seems to be working properly as well. And then going to the higher voltage range, our constant current set drops to only 1/4 of an amp, 250 milliamps max. We should be able to take it up to 120 volts. At least this device will go a little bit over, at least 10% over. So according to its display, we should have a good working device. So now's the fun part. I'm going to get some resistive loads involved. I have, for the 120 volt excuse me, for the 120 volt range, I have a 100 watt 500 ohm, which measures out to about a 489. This is a overseas produced item. It seems to be close to value. Since that 120 volts should only put about 30 watts through that. And to double things up, I have a second one of about the same value. So we can parallel those, have the resistance, and put a 250 well, actually we need about 120 ohm load on the 60 volt to get 1/2 amps out of it, to get a 1/2 amp out of it. For those guys, I've got some ceramics I can parallel. 20 watts, 500 ohms. I could just parallel them with those as well. But that's going to be my plan for loading on this guy. I'm going to try to set only about a 2-minute time limiter, so I don't really need to stress the living bejesus out of this thing. I just want to make it, see if it's operational, take a quick look around inside with a thermal imaging camera just to see if I catch anything. out of the ordinary. So we'll go with a 2-minute timer on it. The one thing about this particular, these banana jacks though, is you're going to need something with an exposed plug on it. It's not like it's a socket into a meter. These smaller diameter wires might add some resistance to it, but it's going to be nothing too out of the way. So we have a load on it now. I'm going to go up to take it up to a full 120. So a little touchy there. We're getting doesn't like really fast changes on that, but we've got 126 at volts at 250 milliamps going into it. I can verify that with a digital multimeter quick, just to make sure. It is 126.75 on the DMM. Out of curiosity, I'm going to check the ripple voltage. Ripple is very low as indicated on the meter. Now we might go 5 minutes. I've got my meter set on AC. And just to double check that again, it's actually doing a really good job of ripple management. It is less than a millivolt of ripple at full load. And now to get the thermal imaging camera going. I decided to buy this product a little while back. I might let this go a few more minutes. This resistor is throwing off some heat, but it's not under severe load. This camera is a little different than some. It's got, I'm going to go up and do another 3 minutes on this. I like about this camera is it does have temperature displays on it for the coolest, the hottest, and then the center screen. And in this case, it's, you can see it's locking onto that aluminum resistor, and it's got 320, over 320 degrees Fahrenheit, about 319 where I'm pointed. And then as far as other things going on in here, don't really see any terribly high values. Let me maybe shut this off. I have one heat sink on one of the linear devices. They're actually pretty cool. That's all internal power or housekeeping though. The only other things that you would think that's going to load up, there's a little bit of heat on that one rectifier, but that's only 87 degrees, 92 degrees. Let's see if I can point this over here. The one white hot spot you see is a rectifier. I think there's one on the other side as well. That one itself too is only less than 100 degrees. And our two larger TO3 packaged transistors on the back are cool as cucumbers. And this resistor is definitely cooking. But it's almost at the end of its test there. It's up to 400 degrees. So it's what seems like it's doing a survivable function. Just going to let it finish up its last few seconds here and then work out our load for the 60 volt. Okay. I'll shut him down. Out of curiosity, I want to see what the value is on that resistor now. It's up over 400 degrees. $518 ohms, so it did go up a little bit. It's dropping as it's cooling off, but that's going to be one hot potato. We're going to have to let him sit off to the side here and cool off a bit. The silicone pad underneath it is quite warm. So if you bear with me a minute, I'm going to figure out how to parallel these guys. Get myself down to a... I'm just going to do some wire twisting. Nothing too complicated. If this was a more professional content channel, I'd have these pre-made. That's not the case. Now we have to see what type of connection I can get to this guy. Stack some short leads onto here and see if they'll go down in my range. Well, I might as well not bother setting the current until I actually get things hooked up. Okay, it looks like we have a load. Take it up to 60 ohms or 60 volts. And we're getting warmth. Got our DC voltage. Oh, that was millivolts. 66.18, so spot on with the meter. Check our AC ripple. About 2/100ths of a volt. And get the timer going again because the timer decided to time out. Oops. This is a HTI model HTA1. If anybody's interested, there's some reviews out on this already. I'm not going to cover a lot of it, but our resistor bridge setup is starting to enhance its thermal output quite nicely. That one hot spot there, my fingers over it, it's actually reflectivity. I'm putting my finger right on the transistor there. It's cool as a cucumber on both TO3 packages. And this is probably going to have the same warmth. It's going to have a little heat on that regulator there. It's 105 degrees on one bridge rectifier, or rectifier I should say. There's another one back there that's 100 and getting a little warm, 163, 64. That's probably one of the hottest spots within this unit. There's some thermal footprint on here. I think this might be, let me take a look and see if I can pinpoint this one. Found it's best to, due to the parallax error, it's best to just take a stick and poke around onto something, and that's actually, there's actually nothing there. It's a reflection. These things are kind of strange as doing things like that. Here's something here that is also a reflection. I think I did find one or two resistors on here that did have some and just feeling around with my hand, I don't really feel any type of large convection oven situation here. We're still putting out a good 66 volts, and our resistors are hot spots around 260, 261. So I'm just going to let this run out the rest of the way. There's really no surprises. It seems to be functioning well, and let's take another look at the ripple again. And I'm still set on AC. Ripple has actually gone down, or I didn't have a good connection before. It's 0.003 of a volt AC ripple. And our voltage output is still about spot on, 67.02. And we have reached the conclusion of the preemptive capacitor replacement and rework of the Hewlett-Packard E3612A power supply, along with modifications. I hope that you enjoyed the video content and gained some knowledge of it if you are interested in doing some work on yours before things get out of hand and those capacitors inside decide to cause problems. If you can get to them beforehand and up the voltage on that one capacitor, it is highly recommended in order to keep the unit in good working condition going forward without having to worry about your printed circuit board getting damaged. And I hope that you return for more content on my channel in the future. And if you like what you saw, please give it a thumbs up. And if you are interested in getting notified on new productions, please subscribe. And I hope that you stay healthy and well, and hope to see you again soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.